All right, let's get started. Good morning to all of you who are in the room. Good afternoon, or well, wherever you may be if you are online. I'm excited to be here today. It's actually really good to be back in London. Yes, I'm an American. Forgive me. Hopefully I don't have a crazy accent. We'll play a little bit of a game. No, just kidding. You will learn where I'm from. You probably won't expect it, but that's okay. I lead developer relations at Spacelift, really a pandemic-born startup, which is pretty cool. I've been doing startups for a while now, and you'll get a little bit of background about me. And I'm going to lose some of you right here, potentially. I'm sorry. I'm an Arsenal supporter, so forgive me. It was a great day Saturday, I'll just say that. I was live and in person. That was my excuse to come to London, besides being here, and meet with some customers. So a little bit about me. I am a reformed enterprise architect, and yes, I do lead developer relations, and I've been doing this for like 5 years now. I'm not a developer. Originally was not a developer. I have updated and uploaded my peers' keys to AWS, or AWS keys to a public GitHub repo. It wasn't on purpose, but I have done that. Fun story. It actually involves what we're going to talk about today. I spent almost 10 years at VMware, a little over 10 years. Actually left, went to a startup, got acquired, went back, made a couple acquisitions while I was at VMware, did a bunch of different things. I started as a customer. I started not on the vendor side, but I was a customer. I was one of you. And really the best thing about that is I have that empathy. I still believe that at the end of the day, having a customer mindset is probably one of the most important things. I am a DevOps fanatic. Actually, I would like to add security to that as well. Going back to me, uploading my peers' keys to GitHub. I am a Texan, but I do love seafood over steak. So I always like to keep my talks a little bit of fun. And so little random facts here and there. You might judge me if you like steak. That's okay. But I like seafood. And so, yeah, that's a little bit about me. Hopefully you don't think I have a Texan accent. A little bit about Spacelift. So Spacelift, this is like the most marketing slide we have. We are really all about collaborative infrastructure. That's really what we do. It's what we focus on. And you can see some of our customers that we have to date. Some based here in the UK, all through Europe and the US. And so I'm pretty excited about what we're doing, and I think our customers are as well. And hopefully you'll pick a little bit up of what we're doing a little bit later on. I'll give a kind of a quick overview. So who uses infrastructure as code? Raise your hand. Who doesn't know what infrastructure as code is? It's okay. Yes, the video guy in the back. Some people always ask, why do you put this slide in? Just to set a baseline. Some folks, when they see infrastructure as code, they think of many, many different things. I use one of my favorite definitions is actually Microsoft's modern definition, if you want to call it that. But it's basically codifying or codifying, depending on how you like to say it, your infrastructure into code, whether that is Terraform, Pulumi, AWS CloudFormation templates, YAML. Everybody loves YAML. Just kidding. Personally, I hate YAML, but I work with it every day. It's like, yeah, it's a necessary evil. At the end of the day, IAC is a good thing, and we've all been on this journey. Some of you may have just started. Personally, I have been on the infrastructure as code journey for about 8 years. It's really from the beginning. So I've been through every stage, all the way early Terraform stage to different iterations. So here's what we're going to talk about. And kind of navigate a little bit. And feel free to ask questions both in the room and online. This is definitely collaborative. I do not want to be the only one communicating. So if you have any questions, definitely bring it up. We'll focus on building locally. And then I will tell the story where a DIY solution, CI/CD solution, I uploaded my peers' keys to GitHub. They won't let me live that one down. It's happened. Sorry. Now there's things that GitHub has done to prevent that from happening, which is a good thing, because I'm a human, I make mistakes. And I would assume everybody in here makes some functional mistakes. And then we'll talk about open source. I'm a huge fan of open source. In one of my previous roles, I supported a platform called Terrascan, a company called Accurix, which was acquired by Tenable. And Terrascan was a security-focused infrastructure as code tool. And so definitely something to think about. And then we'll talk about some of the purpose-built solutions, right? Whether that's Terraform Cloud, Terraform Enterprise. We could talk about some of the other startups in the space. And then I will obviously talk a little bit about Spacelift. So pretty simple diagram. This is nothing new. It hasn't changed much other than some of the providers. And obviously that's grown, the ecosystem has grown over time. But I remember back in 2014 first being introduced to Terraform. Early on. And the goal of Terraform is pretty simple. I take what I want to do, in this case an EC2 instance, and at the time US East 1, and I want to pick, I don't know, 2 CPUs, 8 gigs of RAM, and provisions that EC2 instance and let it go, right? I did that on my local machine. I had all of my code locally, and it stored state. It had all of the information on a local system. What was great is when that system broke and you lost state. You had all these assets in AWS, or you're at the time doing it on VMware, and great. They were provisioned, they were working, but at the same time, I couldn't necessarily make any additional Terraform changes because I didn't have the code. Right? But the ultimate goal in that case is you could take the basic Terraform instance or Terraform code, you could plan on it. Hey, what is this actually going to look like? Can I take my required parameters? Is it available to me? And it's pretty simple, and then here's what the changes would look like. Here's what your VPC would look like, all of that good stuff. There are so many different assets you can provision in a public cloud. I'm not going to go through all of them, so I'll be very generic in the things that I mentioned. But then when I actually submit or run a Terraform plan or then a Terraform apply, it will then provision said infrastructure in the public cloud or VMware, whatever your choice at the time, OpenStack. I did use OpenStack. I had to. It was kind of fun. And then ultimately the goal was to simplify that, right? We were becoming developer-centric, DevOps-centric in the infrastructure world. That was super early on. But we did it, and it worked. The one issue I know I had specifically with building locally is it was great for individuals, but when you start working in teams, it can be an issue, right? How am I, if I'm trying to provision 2 workloads and my peers trying to provision 2 workloads, are they competing in any way? Are we trying to create multiple VPCs and we run out of elastic IPs? It gets pretty confusing at times. And then if I leave the company or they leave the company, where are their assets? We've got the workloads, but we don't have the state and the information that's associated with them. And so it just became a hassle in a lot of ways. It worked, but there were some limitations. Then this is the epic kind of path that I took. I was on a team of 6. We built this lovely application based on Django with a web front end. It had a couple of databases, database backend. What you see this diagram here was actually a generic architecture. This was what we showed publicly. You can actually go to the repo. We still have this generic app. But at the time, it was okay. I mean, it worked. It was built on top of EC2 instances at the beginning, and then we actually transitioned it to Lambda and containers and serverless kind of as the maturity of the infrastructure underneath. But what I want to say is we had to take multiple Terraform files that had different stages that had to be run, right? You had to have the apps before you had to, or excuse me, you had to have the databases before you had to have the app, and then before you had to have the web front end. If they weren't services, or they weren't connected, they weren't working, you literally had to wait. So doing this manually was a pain, right? I would literally sit there, Terraform plan, apply, and it would deploy to database servers. Great, that's just fun to sit there and watch and wait. Developers had already started using things like Jenkins and CI/CD pipeline solutions, and so we felt it was good to try and take those solutions and actually build the application, deployment lifecycle into it. And so we did. we took Jenkins and we took Ansible, and we built an entire application infrastructure from infrastructure to application all within Jenkins. And if anybody has ever used Jenkins, you know the pain that I felt and still feel today. Yes, forgive me. I feel for you too. So then we took that and said, okay, well, let's do it in GitLab. And this was like a couple years later, using runners. And GitLab actually worked out pretty well. It was still a YAML file, unfortunately. But the idea was, let's take all of these manual steps and automate them in an application-centric fashion, or an SDLC fashion, which you should. It is the whole kind of purpose and process of DevOps, is really the maturity around it, which was fine, except the hacking that took place to make this work was difficult. It was difficult to maintain. Changes to Jenkins would break things. Changes to GitLab would break things at times, right? It wasn't all, terrible, but obviously there was some work that had to go into it. And I can say this is the case where don't ask. So we had one of our peers. He did some work. One of our other peers gave him his AWS keys, hard-coded it into the Terraform code. Did not, this is where it gets funny, he did not have access to our GitHub repository. So he literally zips the files, sends them to me, and is like, hey, just put them up there, we're good to go. I do that. I don't look at, this thing is like 7 folders deep. This is the application, right? I'm not going to go look at every bit of code. It's not my responsibility. They validate it, good, I'm moving on. Yeah, I upload to GitHub. It took 20 minutes. That quick. My coworker's AWS account, thankfully he didn't, it wasn't an automatic trigger to our production account, but it was to his individual account, and yes, AWS shut him down. It was pretty fun. But the work to get through that, I still get blamed for it. That's fine. I'll take the heat, whatever. But that's the kind of problems that have evolved with infrastructure as code and going from individuals to teams, right? So it's not perfect. And one of the things that we saw during this kind of, what I would say is kind of the first generation stage, is the incorporation of traditional tooling, Ansible. Maybe you use some of the traditional VMware or Red Hat or HP tools to do configuration management. And so there was this weird kind of intermingling of technologies that became a little bit of a hassle, but we made it work, right? And we're using tools that are available. So here's some of my thoughts. It worked, but we couldn't take that and share it with a new team member, right? Or we couldn't take what we had built and easily make it portable to elsewhere in the organization. So in our case, it worked, but unless you built it, you didn't know what you were doing, right? And you're probably like, that's pretty much all applications. Yeah, it's pretty much the case, at least at this at that stage, or when we were doing this. That shouldn't be the case anymore, at least I hope so. Documentation and enhancements in technology hopefully have helped us out. The one thing I have seen, though, is while we had improvements, there was still isolation, right? Even though it's just an example where we had one of our peers create some code, included some AWS keys. He built it in isolation. It was not meant for public consumption, though, right? So isolation is a good thing in some cases, but it's also, it can be a problem. We also saw maturity with tooling, right? Whether it was Jenkins, no offense to Jenkins, or Jenkins X, it's even worse. But sorry if you love Jenkins. I'll give you a hug later. I don't. And then we saw maturity with GitLab. One of the fun things with GitLab, actually, during the process, they included a vulnerability scan capability within the pipeline. And so as I mentioned earlier, we took the application and actually converted it to containers. And we used the vulnerability scanning capabilities and assessment within GitLab to not only provision workloads, and the infrastructure workloads and the application itself, but the containers that they were running on, we would run security checks Every time the deployment was built, if there was new changes, we would look at different libraries that were in the containers, right? So there was improvements, but there was still some maturity challenges, right? And it obviously takes time. And there is lots of hacking involved. I'm not a developer, I said that, I'm a hacker, okay? Some of you are actually developers, I'm not. I can't create something from nothing, but I can hack around a little bit, right? So that's what we did, and as a team, we did it. The other thing is, as I already mentioned, we repurposed tooling, right? Jenkins was not meant to build infrastructure. Like, let's be clear. It was meant to build applications and provision applications or different assets, libraries, and so on. But we made it work, right? And we did that partially because we used Terraform and it's in code, as well as some of the other aspects of the life cycle and of the stack. But at the end of the day, we had to repurpose a lot of these things. And so that's, as a journey. Like I said, I've been on this journey for 8 years now, right? Things are a little bit different today, and you're probably like, maybe I didn't want to see some of those challenges and difficulties, but we did have them. Now, as I mentioned, actually, I'm going to take a pause real quick. Any comments or questions kind of on that early stage journey? Maybe you are on a little bit of this early stage journey. Any questions? Yes. And so in the early days, nothing. We built it. Like, so put it in context. I worked at VMware, right? We were a software company, so we could go build these things, right? In our team, we did that to build out some assets. But at the time, commercially, there really wasn't. I mean, from an open source perspective, obviously you had Terraform. AWS then came along with CloudFormation templates. Azure had Azure Resource Manager, ARM templates, which was a good thing, right? So there was a proliferation of infrastructure as code, but to actually plug those into a full-on SDLC or DevOps methodology and principle and practice, they were not around. Yeah. I would like to think they're around today. We'll talk about that in a little bit, though. Anybody else? No struggles with infrastructure as code. Did anybody struggle with original, like, straight up infrastructure as code at the beginning? Yeah, we all felt it. We just don't want to admit it at times. So then came along open source. I'm a huge fan of open source, and I'm a huge fan of Terragrunt. Terragrunt was good, right? If you know anything about Terraform or building mono repos or large-scale architectures with both the infrastructure and the application, you get this lovely folder structure that gets really out of hand. Here in a little bit, I'll actually jump into my demo environment, and you'll see a little bit of the craziness. And I'm just doing a couple of demo apps. But imagine having 30 apps with web, DB, front end, back end, load balancers, right? All of these different assets. It just becomes sprawl. And contextually, you probably understand it. Maybe you do, maybe you don't. But it happens. And then the thing is, with Terragrunt, we also were they added the capability of running Terraform commands against a module at the same time. So a module is basically a folder structure or a single folder with multiple Terraform assets inside of it. So you can't run a Terraform plan or a Terraform apply against multiple Terraform files at once, right? Unless you just have multiple command line windows open, but that sounds terrible. And so what Terragrunt did is introduce the capability to run things in parallel. Right? As I mentioned earlier, if I'm trying to remember because it's been so long, I believe we deployed the database load balancer first, the actual infrastructure itself first, and then we deployed HA proxy, and then we waited, and we waited. By the way, HA proxy worked. It was great. And then we deployed a couple of databases, and we waited. Right? Database 1 came up, database 2 came up. We configured HA proxy to make sure they would do the right thing. And then we deployed the apps, waited for one side, waited for the other side, right? Like you could just start to see if I do this at an individual basis, one Terraform command at a time, it just becomes a problem. And then obviously web front ends, all that good stuff. So what Terragrunt did is we can now run these things in parallel, which is fantastic. I now can deploy an HA proxy, 2 database servers, 2 app servers, 2 web servers all at the same time. It cuts it in half. And so that's a good thing. Now, the other problem we saw with just generic Terraform at the time is you couldn't run custom hooks. So this is where things like GitLab, and in my case, GitLab and Jenkins came into play, is because we were able to run some specific things that were focused on our team and our organization, right? In that case, we used Ansible, right? So we would click Terraform, or do a Terraform apply. Once it's finished, we would run a custom hook or a trigger to kick off an Ansible playbook, or Chef playbook, or cookbook, or whatever they were called at the time, right? So we were able to utilize some of the existing technology and configuration management tools that were out there with Terraform. Okay, and so it actually became functional, right? Open source in a lot of ways is solving a problem. In this case, solving a problem that Hashi had no desire to solve. It wasn't theirs to solve, so they just said fine. And the team behind Terragrunt built it. Has anybody used Terragrunt? Yeah, good. Do you like it? I mean, it works, right? It's what it's for. It's pretty fantastic. Then along came Atlantis. Who uses? Anybody use Atlantis? Perfect. So here's one of the fun things. This is kind of the introduction of the team and collaborative effort within Terraform. And one of the things I love about DevOps is kind of, or in modern DevOps, I feel weird saying that. We've been talking about DevOps for way too long at this point, I guess, is this notion of GitOps, meaning everything is in the repository. We're going to manage all changes to our infrastructure based upon PRs. It's pretty simple. In the development world, as an application developer, I've worked for multiple startups, big companies, right? So as they create code, they will create a PR and attempt to merge the branch or merge it to main, whatever it may be. And that's great because you can have comments and you can say, this is awesome, right? Why are you deleting my VPC? Right? There's an application that utilizes said VPC, or you're removing some security groups that affect me. Right? You're changing things that break my side of the application or another application, or the infrastructure in general, right? And so Atlantis, for the most part, it provided greater visibility, right? It tells you what is going to change, right? Anytime you run, so it would actually start a Terraform plan. Those output and those results would come out, and before you ever ran a Terraform apply, you either had to get approvals to merge that PR, or like I would like to complain because you're breaking something. And then what we actually saw is this capability allowed security to get involved. And so I can run vulnerability checks, and I can run security scans on whether it's my IAC, on whether it's the configuration and provisioned assets that are in the public cloud. And so it actually, to me, provides greater visibility. And the Atlantis team has done a fantastic job. It helps collaboration, but it creates a workflow, right? One of the big things with workflow, or with that I have seen, just because I've been doing it so long, is the workflow within an organization around development is very important. The SDLC was created for this. But when it comes to infrastructure, we were just kind of like, we'll do our own thing. But now, with so many changes and just the really intertwining of assets and workloads and different public clouds and so on, that workflow becomes very important. And so do I need approvals, right? Yes, you need an approval from multiple teams before this happens. And so developers, security, infrastructure, all of those. And now Atlantis provided those capabilities. My only problem with everything kind of up to this point is it's all focused on Terraform. And so we'll talk about that in just a little bit. Anybody else using any other solutions from an open source perspective around infrastructure as code at this point? Or are you fully utilizing Atlantis? Anyone? Okay, fair. So this is one of my favorite movies. I hope, yeah. Milton is fantastic, but it's a workflow. Like, let's have something in place. So one of the challenges that I personally have seen, specifically around the open source, or many of the challenges I've already stated, it's all about Terraform. Does anybody use multiple infrastructure as code solutions? Meaning, in your environment, you're using CloudFormation templates, Azure Resource Manager templates, Terraform, Pulumi maybe. Anybody have more than just one? Yeah, right. So while things like Atlantis and Terragrunt are great, they don't solve the broader problem because they're focused on theirs. Now, you might say, well, AWS has built a couple of things into their stack. Azure DevOps has done a few things, which is true. But in most cases, we all have different public clouds. We have different assets, different workloads. And so we need to think a little bit more outside of the box than Terraform. And we could also say Terraform technically did not reach version 1 until like 2020, 6 years after it was originally created. And there's a whole open source supportability, all that stuff. The other thing that I have personally seen, because as a team, as individuals, because I've dealt with it, is really the teams in silos issue. Even though I can create my own Terraform and use Terragrunt, and I could save my state in a GitHub repository, and the entire team sees it, the context is still lacking. And the understanding is still lacking in a lot of ways. So when you get into larger teams, right, those silos quickly become known. Lack of visibility. This is a fun one. I'm a graphical person. I like to see pictures, right? I like the picture books. Like if I look in the encyclopedia, it's got to have a picture first, and then the word. I'm just kidding. It's got to have a picture, especially when it comes to my infrastructure, right? We all use infrastructure diagrams, and by the way, they all change. One of the things about infrastructure diagrams or application diagrams is the second you create one, it's already changed, right? And so what I have always liked is visibility. And so there's really, whether it's Terraform itself or even AWS in the public cloud providers, there's nothing that provides that visibility to us. And so that's one thing that I think is very important. That has been solved a little bit in the Kubernetes world to have some visibility, but it's not perfect. So something to think about as well. And then more importantly, what about security, right? Security was never kind of a first-class citizen in a lot of ways. And so over the past couple of years, companies like Bridgecrew, Accurix, Sneak has done a really good job. They've created solutions that fit directly into this space, right, where they're introducing security assets or guardrails or different assessments into the infrastructure as code pipeline. But it's still a manual process, or it's still a third-party step, and it's not included all in one. And so that's where just some of the challenges I have seen today. Anybody else have any other challenges, whether it's on the open source front or just kind of the generic IAC front at this point that maybe I have missed? Anything in particular that you're willing to share? Or any other IAC challenges in general? I can't be always right, so gotta speak up. Anybody? Okay. Everybody's shy today. So let me kind of give a quick breakdown, right? This is so a little unique perspective, right? I'm going to talk about Spacelift. Obviously, I work at Spacelift. I personally have paid for and budgeted for Terraform Enterprise while I was a part of teams. I've paid for Terraform Cloud, and I've worked at a company called M0, and I work at Spacelift, right? I know this space really, really well. I think. And so I think I come from a unique perspective. One of the reasons I joined Spacelift was one of the reasons. There's a couple of reasons, right? Infrastructure as code is multiplayer. What I mean by that is there's more than just Terraform. You can go into a single organization. They will have Terraform, they will have Pulumi, they will have AWS, they will have Azure, they will have Google. They will have whatever infrastructure as code, because that's just the way we do things now, right? And then the other thing is there's multiple teams involved, whether it's cloud platform teams, which is probably one of the teams we see most of the time. That is a Cloud Center of Excellence type of team, or developers who have had to take over infrastructure because their traditional infrastructure organization wasn't very good. Lots of different scenarios, right? But it is a multiplayer world and multi-solution world. The other thing that is more important nowadays is the maturity of GitOps, right? Is just the maturity of teams and organizations themselves, that they are making changes to their environment with 100% track, 100% visibility and understanding, and people are having to go through, individuals are having to go through checks and balances, right? I can't make a change to a non-prod environment without somebody's approval. And I don't mean that in a I have to stop kind of way, but hey, I'm going to make a change to pre-prod and there's 3 of us individuals who own it, and here's what the Pulumi apply is going to look like, and here's the 4 changes that are going to happen. And it literally sits in GitHub or GitLab or your source control provider, whatever it may be, and you see the changes, right? And it's tracked. And I could come along and say, this looks good, but then a peer might come along and say, hey, we're also going to be making another change for another application, and that's actually going to break, right? And you can do this within comments. It's like such a novel concept. Like these very simple things that we're trying to do. But GitOps has actually introduced a lot of those capabilities. Once again, security. I'll keep talking about security. And here's another thing. Drift detection is pretty important. Who has a problem where they did not revoke AWS or Google or Azure access, GUI access or CLI access, but also use infrastructure as code? Does anybody have that problem? Yeah, right? Some folks do. I've got one nod in the back, okay? So here's a funny thing. I've done this several times. I actually did this last week. Don't know why. I made a change via infrastructure as code. I was then in the AWS GUI. I was doing some different things, testing some stuff. And I went and made a change to one of the workloads that I previously deployed. I am the one who's on the bandwagon that we should not allow this, but I'm the one who did it. Right? It's just human nature. We make changes, right? So I went and made a change. And then I came back. I got a notice from Spacelift like, hey, you went and made a change. And I'm like, oh, yeah. Thank you for watching, right? And that's what it does. That's what it's really all about. And so let me show you how a little bit of this, a little bit of how this works. And hopefully it can kind of catch you up on the journey here. So I've made sure that I don't have any of my AWS keys. Okay, I've done that before. One time I was doing a keynote at GitLab commit in London, and I threw up my GitLab API key publicly. I revoked it within 30 seconds. Somebody told me to, because I didn't. It was just by nature. So this is my repository that I have currently built out. I have kind of 2 folder structures for this environment that we're looking at. I've got DevOps which we'll talk about today. I've got a Kubernetes folder. Underneath that, I have a couple of assets. So it's Spacelift. We support AWS, Google, Azure, but then we also support Terraform, Pulumi, Kubernetes, and I think I'm missing something. I'll think of it in a minute. So what we do is we actually run Spacelift on Spacelift. So we actually have a notion of workers. And so what I've done in one of my environments is I deployed a Kubernetes cluster in AWS. Then I deployed another Kubernetes clusters in AWS. I deployed our Spacelift remote runner worker images on top of Kubernetes, and then deployed an application all within Spacelift. So it's kind of fun. But for today, I'm just going to show you the code to deploy a Kubernetes cluster. Via EKS, here's my VPC. This is all my Terraform code in here. It's got my VPC, it's got my security groups, my EKS cluster, all of those fun things. I've actually already done these standard, git commit. I did git add. I've already pushed all of this to my repository. So it's sitting in GitHub. I'm not super brave to actually do this live. So here's my here's my repository in GitHub. Here's all the code. It's pretty simple, right? But nothing has happened yet. So then I went to Spacelift, which is this stack right here. And it failed 3 times because I mistyped something, because I do make mistakes. But at the end of the day, I provisioned a cluster. And here's what kind of the process. I'm shrinking this just for the sake of time. But here is my preparation. So I'm building a runner. It's going to provision a runner. And then I do my Terraform plan. Now, if this was Pulumi, it would be the same way. If it was Kubernetes, I would actually just run a customize YAML. But here's all of the things that are going to be added. I'm literally just scrolling, because this is a VPC. This is multiple EC2 instances, an EKS cluster, and so on. And so this is what everything that's going to be added, right? And then I came in here an hour ago, as you can tell, literally right before I walked up here, or walked down here, and I went ahead and applied this. And then it built the cluster. And so here's my apply, and here's the output, right? It shows me all of the aspects and all of the assets that were created, 53. And it will tell me all of the things, right? And so as we've talked about with Terraform, state, we've talked about the user workflows. I could have commented if I wanted to. Now, I'm commenting to myself because I'm the only one here, right? But our team, actually, a good example for us is our pre-prod environment is fully run on Spacelift. And any changes, any comments, they are not made in our VCS. They are made in our platform, right? And so they're historical, they're tracked, they're audited. There's all those good things come into it. The other thing I didn't show you is the settings. So in my case, for my EKS cluster, I did not, I set up permissions for AWS. So you have some AWS details there. It's okay, I don't care. It'll be gone by the time I leave. And then, from a settings perspective, I have my repository that sits in GitHub, and then I chose my Terraform backend. And so just to help kind of show this a little bit more, let me show you what it looks like for Kubernetes. So this is my Kubernetes instance. This is not a good run to look at. There we go. There's all my changes, but here's what it looks like from a plan perspective. So once again, here's everything that's added from a Kubernetes point of view, and you can write directly to a Kubernetes cluster. So in the previous instance, it was Terraform. So I just had to have AWS integration. In this case, I actually had to connect to an EKS cluster. So I have a pre-provision to update my EKS cluster and connect to that the runner will update and connect to the EKS cluster, and then make all of these fun, lovely changes for Helm and deploy our runners. And so the key is when we look at this, I'm showing you just kind of the graphical perspectives. We could also look at policies. I'll just show the base policies. We can get very creative on this. We use OPA. So is anybody an open policy agent consumer or user in the room for policy? So what we've done is OPA is an open source policy creation or a policy framework, and we can utilize OPA to actually take action. So we have, at Spacelift, we have developers, right? They're the ones creating our applications and provisioning infrastructure and so on, and actually provisioning our customer instances, right? But then we also have solutions engineers, which are somewhat engineers, but they're not actually the developers. And so our solutions engineers may need to get in and access and do some things that our developers need to do, right? So we've set up policies and permissions of who can run a Terraform apply or a plan, all the way to very specific resources and assets within Pulumi or Terraform and so on, because we understand that there's multiple users, there's security involved, and we can audit all of this, right? Simple things, password strength. I don't have to anymore, but you can enforce do not, like if you see a string that looks like an API key from AWS, don't actually apply, right? Because we're looking not only at the code itself, but we're looking at the output. And so it gets pretty unique of what we can do. And then another capability is kind of in one of my previous scenarios, as I mentioned earlier, with, a team of 6 of us. I was the owner of the infrastructure and the traditional Django app, right? That was my responsibility. And so I own the infrastructure, I own the provisioning. If something needed to change, I was the one to make the change. But then one of my peers, he was kind of my backup and kind of counterpart, but he was responsible for taking that and moving it into containers, right? And so in that example, he only had read-only access to my environment, and I only had read-only access to his environment where he was spinning up the Kubernetes resources and doing testing, right? And so it just depends on the scenario and where things are at for you. And I just wanted to kind of give a day in the life of what it looks like. So I've taken what was a local build, I've now pushed it all into a public worker pool that allows me to do everything remotely, so I'm not having to do it all on my own system. And we allow that to spread across teams. We check state, from there. We have actually integrated the entire Terragrunt and Atlantis workflow into this. That way you can continue to have PR, GitOps, custom hooks, if you want to call Ansible, right? Today you can do that. We're going to actually add direct integration with Ansible. It's just some of the things that we've been able to do and continue to look to accomplish and add as we move forward. So I'll pause there. Any comments or questions on anything I've shown, talked about, generic, Spacelift, infrastructure as code, or anything else? And if you haven't figured it out, I'm a big fan of Toy Story because I used 2 Toy Story memes. So, yeah, that's it. My name's Sean. I'll be here rest of the day. Thank you for coming out this morning, and I really do appreciate you. Without you guys and gals, I really would have no reason to be here today. So your presence is greatly appreciated. Thank you.